Hello, welcome back to Cracking the Cryptic on the day we've launched our Patreon reward for December, the wonderful snack doku pack of 100 4x4 puzzles. Do join us on Patreon, have a go at that. It won't take you as long as it sounds like, and there's just great fun to be had along the way. Do check it out. It's on Patreon. You enter via a Google form that can be accessed from the document, and we're expecting a lot of answers in. I hope it's gone well, because I haven't been available from 4 today to fix it if it hasn't. But there we go. It's up and you can play that, and it's great. Now, I'm going to put out an appeal as well. Does anybody have skills with programs like After Effects or anything similar? We have a card at the beginning of our videos that appears during the music, and it features slightly outdated descriptions in my case of myself. Simon's is probably still fine, but we'd like to, if anybody has the skills to remake that. The chap who originally made it for us can't be contacted, it seems, anymore. So unfortunately, we're looking for somebody who could remake that for us. We have, as you know, no technical skills, and some help would be welcome. If you want, please email us. Now, what else have we got going on? We've got all our apps. Check those out on the links under the video. We've got a merchandise. We've got Sven's SUDOKU PAD, and of course our Kickstarter. If you want more, well, if you want Fog-of-War puzzles at Christmas, that is the place to get them. And as well as Sandra and Nala contributing at least 10 puzzles, there are going to be a number of luminaries from the world of Sudoku creation joining them. It's really going to be worth it. So do pledge to the Kickstarter if you would be so kind. But the first link under the video is to this puzzle, which is rather brilliantly called There Are Threes in the Corners by Bruce Savary, who has come up with something absolutely extraordinary. Look at all the threes around this corner. So the rules, let's do the rules. Normal Sudoku rules apply. We're going to place 1 to 9 in every row, every column, and every 3x3 box. I'm sure we are. Now, these are little killer clues, they're called. A clue outside the grid sums the digits on the indicated diagonal. So those 5 are going to add up to the 33 clue pointing at them. They can include repeats, that's fine. But what a construction. I mean, you couldn't get more 33s, more 3s around the corner of this puzzle. It's an absolute genius idea. I can't wait to see how it unfolds. It may be a brilliant solve as well, but even if it isn't, it's a brilliant construction and idea. Check it out. So let yourself play it or watch me. I'm going to restart my clock now. Let's get cracking. So the place we get cracking, I mean, the title of the puzzle is There Are Threes in the Corners, and I thought that was just referring to all the threes that are outside the corner. But we have 2 one-cell clues, and in a little killer puzzle, you can fill those in straight away. So it's a full party. That's 3 in the corners. That's 3 in the spot. Lights losing their religion. Anyway, brilliant. Now, these 3 clues are 2 cells, so there are 2 and a 1. That's straightforward. Then I think the puzzle gets a bit harder. What's the maximum for a 4-cell diagonal? It's not far from 33, but 9, a 9-8 pair, and 9 adds up to 35. So there's 2 degrees of freedom there. And that means this is a 9, definitely, because we can't reduce it to 8 or 7. And going down to 6 would take a 3rd degree of freedom. I suspect a lot of this puzzle is going to be about degrees of freedom. So this is a 9-8 pair. Now, one of these could be a 6, because reducing a 9-8 pair, which adds up to 17, down 2 degrees of freedom takes it to 15, which could involve a 6. But this is 9 or 8, because that can't come down to 7 either. This is better. This 33 diagonal in 4 cells is better. In fact, because of that 9, this is max now. 2 8s there is 16. 8 and 9 there makes up the total to 33. So we can fill in 8s. In fact, we know which way 8 and 9 go because of that. So there we go. We've done another diagonal. Now, I think to discuss this puzzle, it might be worth colouring these diagonals. Or lines. I don't know. Let's colour them first. So we'll go blue, orange, bright green. What can we have? We'll have a red one. This one can be bright blue. Then we'll have yellow up the long diagonal. I can't see any of these yielding immediately to just thinking about them. They don't seem extreme enough. Now we've got to have some repeats, I imagine. So we'll go orange again. Oh, I haven't used purple. Let's do green first and then purple. There we go. So this is just to discuss. I mean, I've done this one already, so maybe that doesn't get a colour. Now I can discuss the orange diagonal and the green diagonal with you so that you know what I'm talking about without me pointing all the time. Now, let's have a look at this one. Yeah, this is interesting because 7 and 6 are max there. That's 13. 7 there is 20. Now, if this wasn't a 9, 7 and 6 would be max here, and that would be 33 for the whole diagonal. So that is possible. But if that is a 9, I suppose then we have some degrees of freedom on the others. Someone tell me if that's a 9. I can't see if I should know that. Oh, there is some Sudoku going on. 8's in one of those two cells. 9, actually 9 is in one of those two, and I want to know if it's there. Ooh, can 9 be there? 18, yeah, these 21, 24, 25, 8 degrees of freedom, that's not great. Now, the other thing we can do in Little Killer puzzles is to amass. Okay, I'm going to colour this diagonal after all. Is to amass diagonals together. And I'm quite interested in bright blue, yellow, and dark blue. Now that's not why I coloured that 4-cell diagonal. Now let me try and do my thoughts in order, try and arrange my brain in case it helps. Now obviously the total of those 3 diagonals we're given down here. They're all 33s, so that total is 99. However, a bit of simple set theory, if we compare that with the totals of boxes 3, 5 and 7, which is, I hope you know the secret, which is that every row, column and box in a Sudoku always adds up to the same number, 45. Only share that with people who you trust. Anyway, those 3 boxes add up to 135. Now the difference between that 135 total and the 99 on the diagonals, the numerical difference is 36. But how is that represented in terms of cells in one but not the other? Well, I think it's these cells, and let me letter those. Oh, I can't letter them all. That's annoying. But if those cells were all labelled A, those cells are not included in the diagonals, but they are in the boxes. Whereas these cells are the opposite. They're included in the diagonals, but not the boxes. So that 36 difference between the diagonals and the boxes is representative of these 6 cells minus these 4. And that total must be 36 as well. Now, the max for those is 9 and 7. Neither of them can be 8, so that's 16. For these, it looks like 8 and 9, 33. And for these 7 and 9, that's 49. The difference I wanted to come to was 36. So the B's then, given maxes in the A cells, would have to add up to no more than 13. Oh, there are more degrees of freedom than I was hoping for there. Bother. Okay, now, why, okay, well that was one thought. I did want to share it with you in case it was profitable. I think the next one is even better. Right. Look, the whole, yes, this is why I coloured that yellow section. The whole coloured section of the grid, we know that number. And that is 33 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How's your mental arithmetic? 33 times 11 is 363. Now, what is the total of the whole grid? Well, we know that every row, column and box adds up to 45. 45 times 9, 405. Well done, you're ahead of me. So, if we subtract 363 from 405, you can do that in your head too, it's 42. We get the total of the white cells. And if we subtract those white cells from the total of the two boxes they're in, which is 90, 45 times 2, we get 48, and that is the perfect number that we want. This is where we start. Because 48 in 3 cells that don't see each other, that do see each other and can't be the same, twice is 987, 987. So I can fill in a 7 there, and this is a group of 987. So there's no 6. Those are from 987. And now we have a 456 triple in box 1 and a 456 triple in box 9. And they couldn't have had 33 clues because they only had up to 15 each. And now what do we do with that information? Because it hasn't really advanced anything, but we got that 7 on purple, didn't we? And purple was interesting me before. Now, if... no, it gets more interesting. Look at that 7 and that 7. They rule out 7 from all of those cells. So now there are 3 7s in purple because we can do the same in this box. They're not 7. So in this box 7 is purple. In this box 7 is purple. In this box 7 is purple. Purple includes 3 7s equals 21. Oh, this really is a mental arithmetic workout today. And 2 other cells that add up to 12, 1 in each box. Now it can't be an 8-4 pair. It can't, it could be a 9-3 pair. It can't be a 7-5 pair because we've used 7s already to the max. But remember, it could be a 6-6 pair and it could be a 9-3 pair. Now, if it's a 9-3 pair, the 9 is definitely here and the 7 is here. Then these would be a 3 and a 7. And we know which way round they would be from the 3 in the corner. So that's one possibility. On the other hand, it could be a 7-6 pair in both boxes, and I can't even see any 6s in the grid to tell me which way round they would be. But we're left with these possibilities. I just don't know which is which. Oh, look at this central box. There's an 8-3 that can't be there. I hadn't seen this. Sorry, this is probably the obvious thing to do. Right, 4-6 pair, and that takes 6 out of that cell. So, has that changed the dynamic? No, not really. That can still be a 7 if that's a 9. That's a pity. Okay, the other cells in column 5 are 1, 2, 7, and 9. They're a bit restricted. The other cells in this row are 1, 2, 6, and 7. They are less restricted. Okay, let's just keep thinking. This is fascinating things going on. And some of this may be about finding the right things to amass together. So, let's try orange and blue up here. because 66 is quite a big total. Right, 66 is the total of blue and orange from the little killer clues. Take out the 7, 8, 9, which adds up to 24, and we're left with 42 in these highlighted cells. Take out the 9, we're left with 33 in these cells. But we also know that orange on its own adds up to 33. So the difference between the highlighted 33 and the orange 33 says that that cell is the same as that cell. I'm going to give them a letter C, because I don't want to forget they're the same in case it's difficult. Now, there must be a 7 in these. 9, 16. Yes, the way to look at this is that these 3 cells add up to 24, which is 33 minus the 9. And I don't think, once C is there and there, we can't have any repeats, because obviously that's a set of 3 different digits. So that's now a set of 3 different digits, and they do add up to 24. I think I just proved that 2 equals 2 there, fairly pointlessly. Oh, that can't be an 8. That's just obvious from this. So one of those is an 8, and that cell can't be an 8. Oh yeah, we get these weird things. Oh, that's the only weird thing we get out of that. I wonder if C is 8, that's an 8. If C is 9, we've got an X-wing on 9s. Yeah, that doesn't do anything. Let's have a look at this again. 33 here. Oh, can that be a 2? Or a 1? If that was a 2, plus 7 there is 9, plus 9 there is 18. I'm maxing everything else out. And we can't have 9 and 8 here. So we could have 9 and 7. We get up to 34. Oh, this can't be a 7. Hang on. I didn't see that. Sorry. 9, 8 and 7. The biggest digit this can be is a 6. So if that was a 2 plus 6, 8, plus 9, 17, plus a 9, 7 pair here, is 33. And that can't work, because that would require 9s in both of those positions, but C is the same as itself. And that militates against 9s in both those positions. So this can't be 2 or 1, and it is 7. Bingo. Yes, utter bingo, because that puts a 9 down here. That means we had a 9-3 pair across these boxes, and now we can fill in the 7s. Oh, lovely. Right. That 7 sees this cell. Well, it sees lots of these cells. Well, 2 of those cells. Now, presumably, I don't know, does this work the other way, that this can't be a 2? I should be able to do this in my head, but I can't. Maximum there is, well, obviously 7, plus 6 for the maximum, 13, plus 9 again, 22. If that was a 2, then that has to be a 9 again. You've got the same problem. It does work exactly the same. Those 2 can't both be 9s because of this C equals C phenomenon. So that's a 6. And now we've got a 1-2 pair in the row. That can't be 7. Oh, this can't be 9. Oh, we've got a 1-2 pair there, as well as 1-2 pair there. Ah, this is weird, isn't it? Oh, look, I've got 8 looking at that blue cell. Never noticed that. I think I had that from when I put an 8-3 pair in there. I just didn't see it. So there's a 3 in one of those 2. Now, can that possibly be a 3? 7, 10, 19, 25. Oh, you'd have an 8 here. And those could be different. They couldn't. They couldn't. Oh, hang on. Well, they couldn't be 9 here and 8 here, because there'd be nowhere to put 8 in this box. Could they be 8 here and 9 here? I think they could. We can just get away with a 3 there. That shows how careful you have to be in this weird puzzle. Oh, look, 1 is ruled out of there. 1's in one of those cells, and there's a 2 over here that's in one of those 2. No doubt that does literally nothing. Well, hang on. This is a one. These are from 1, 4, 5, 6 because they see 9, 7, 3, 8, and 2. So that's a quadruple now. Oh yeah, look, there's an 8, 3, 9 double X-wing. So this is a 3, 8, 9 triple. Now, come on. This can't. Well, it could be a 3. If that's a 3, we've got 6, 9, 16, and these would be a 9, 8 pair. Well, they can't be, and this can't be a 9 or 8. It sees them both. Right, that's not a 3, so we've got the 3 in this row. It's there in green. Now, this is an 8, 9 pair. They have to be different because C is the same. So we've now got 30 in that orange pencil marked area. So that is a 3. We do get 1, 3. Now, let's move on to green. 7, 15. We need another 18 in these. Now, the maximum here is a 7. And the maximum here is 6 and 5. Well, that's it. Okay, I can fill them in. 5, 6 pair there. 7 here. Oh, this is so clever. Oh, that's become a 1 by Sudoku now. Good. That's the sort of thing we want happening. This is now a known pair. It's a, well, it's a 2, 5 pair. I don't know which way round they go. This is 4 or 6. I'm very surprised I haven't done that 1, 2 pair yet. I'm probably just missing how to do them. Oh, maybe, no, it's a slightly different setup from the other place. So 2, 4, 5, 6 there. I'm a bit scared of that A and B maths that I may need to come back to, because that was quite complicated. I couldn't really hold it in my head. I was very nervous I was getting it wrong or about to get it wrong. No, let's just soldier away. We're kind of picking off diagonals. I mean, that's so odd that we didn't resolve that 8, 9 pair yet. Is it obvious somehow? I can't see it. Okay, let's look at green, because we got its counterpart green as well. 12 there. So these others add up to 21. Oh, max is quite difficult. So that is maximal at 6. We need 21 from these. Oh, so, okay, one of them is a 6-4 pair and one of them is a 6-5 pair. 6 is the maximum digit in any of those cells. So that's what it's got to be. You can only have 2 6s. You've got to have both of those and then a 5 and a 4. Right, so that's not a 1. There's definitely a 6 in one of those two, so those don't have a 6 in. There's definitely a 6 in one of those two, so these don't have a 6 in. This is 6, 4, or 5, and this is not a 2. Oh. I thought that was going to resolve itself. Or maybe I just might be missing it. No, hang on. This is the only place left for 1 in this box. There we go. So that's a 2 in red. We've done those. It's probably time to add up the 7-cell diagonals. Let's start with this one. 12. We need another 21 in those cells. But that's very average number for 4 cells. And then less restricted than the ones in green were. Okay, let's try red. It's not going to be very different. We've got 10 there. So these add up to 23 this time. Oh, this is a 1-4 pair. I've only just seen that. So that's not a 4. Okay, what was I coming to? 23. Oh, it's getting a little bit harder. Even at the maximum of those two, that's 9. These have a minimum of 14. Well, that's quite big. If that wasn't a 9, Yeah, this is the one. Red is the one. Let me just check this maths. 10 there. Let's max those. We're up to 19. That gives us a minimum on these two of 14. Now I'm going to say, what if this wasn't a 9? Well, it sees 6, 7, and 8. It would have to be a 5. That would have to be at least 9, and it can't be. So this is a 9. That's one of our A cells. Actually, that fixes 8. That fixes C as 8. That's 7, that's 9. There we go. Things are finishing up there. Lovely. That can't be 6. That can't be 4. Might as well do that. They're not resolved. Right, now, we've got now 19. Max here and here, 23, 28. So the minimum for this is a 5. So it's 5, 6, or 8. And it's got 3 degrees of freedom. Oh, that's exactly what these have. So I don't think this, interestingly, this can't be a 6 because let's first of all take the maxima there. If those were all maxima, then we would be adding up to 36. So we have to take 3 off the maxima. And what that does, we could take 3 or 5 there and make it 2. We could take 3 or 4 there and make it 1. But those are very discrete lumps. We can't take 1 or 2 off either of those. So the only thing we can take off this is 0 or 3. So it can't be a 6. It is 5 or 8, which I'm sure is absolutely fascinating and probably no help at all. Oh, look, it's Sudoku. I've got 4 8s looking into this box. That's an 8. And that doesn't tell me where the 3 comes off. One of these is maximum, one of them is minimum. That's weird. Now, is there any more? Yes, look, I can put 9 here, and that's another A cell. I'm going to have to do the AB maths now. What about this one? Yes, it's a 7. Oh, this is weird. Look, I can put 8 in this box as well. Have I finished all the 7s, 8s, 9s? I can put 7 in this box, and then I have. Look at that, they're all done. Okay. Oh, maybe we'll be looking at yellow. But first of all, I was going to do the AB maths. So remember that the long diagonals, light blue, yellow, and dark blue, add up to 99. Whereas boxes 7, 5, and 3 add up to 135. Now that's a difference of those cells, which we can now add up, versus, sorry, the difference between 135 and 99, which is 36, is the same as the difference between these cells, which add up to 49, that's 24 and 1 more than 24, minus these cells. So these cells add up to 49 minus 36 is 13. I'm quite proud of that mental arithmetic. Now, can I do that? Okay, if they were all max, oh, it would add up to 19. If they were all minimum, it would add up to 6. So 2 of them are a bit higher and 2 of them are a bit lower. That's not the conclusion I wanted to come to. But please try and remember for me, when I ask you, what do the B's add up to? Remember, it's 13, because I'm going to forget that. Now, I can put 3 here. That's just Sudoku again. So maybe I need to just focus on Sudoku. I can finish this with a 3 as well. Right, yellow. That's what I'm going to look at next. 11, 18, 26. Oh, these other 3 only add up to 7. Now, it doesn't have to be 1, 2, and 4 because we can have a repeat digit. None of them are a 3, though. So it's either 1, 2, and 4, or 1, 1, and 5. Is that right? Well, I think it is, but I'm not sure how helpful it's going to be. They're all from 1, 2, 4, or 5. Okay, I'm going to mark them as D, and again ask you to remember that just as the B's add up to 13, the D's add up to 7. That one can't be a 1. I did notice that. I'm actually just going to pencil mark everything else. Now, where's 6? I don't know, but it's in one of these cells. Or do I know? Do I know more about sixes than I'm letting myself admit to myself? Whatever that means. It doesn't mean anything, you fool. Yeah, I bet there's more Sudoku that I can do here profitably. I can't seem to eliminate any of those candidates. That's really surprising. Now we've done yellow, we've done purple. Green is waiting for 6-4 and 6-5 to be sorted out. Oh, look at this orange. I haven't looked at that in a while, have I? 10, 19, 26, 28. These add up to 5. Is that right? Is that right? 18, 20, 21, 28. Yes, these add up to 5. Neither of them are 5 then. And one of them has to be odd, and it's that one. 1 there, 4 there. Okay, orange is finished. Now that 1 looks down here. We get the 2 and 1 down there. We get a 1 here. That looks both into this box. Ooh, I'll do red in a moment. I'm going to have to add it up again because I can't remember. But I'm doing the 1s now. I get a 1 in the corner. Oh, that's not going to finish those off for me. They're going to have to add up to 6 now. D's are going to have to add up to 6. Oh, one of my B's has gone away, hasn't it? Okay, I'm going to have to remember where they were, because when you put in the whole number, the corner marks disappear. I mean, we're nearly finished now. I really think maybe Sudoku gets the same. That's a 2 in the corner by Sudoku. Right. So I mean, it's worth checking this anyway. 12, 20, 29, that's a 4. Now I can take 4 out of there, 4 out of there, so I can place 4 in that box. That gives me a 5 here. Now that's not a 5. This is a 2-6 pair. I'll be adding up blue in a moment, I imagine. What have I got up here? 4, 5, and 6. So one of those two is a 4, and that fixes this cell. So that's a 6. Now I can finish box 9. Actually, that might be a neat way to get finished. 6, 2, 5, 6, 2. That's a 6. That's a 4. That's a 5. That's a 6. That's a 4. We can do 5 and 2. Now, I was going to add up blue. I mean, it's worth checking these things. 10, 17, 22. These two add up to 11. They must be 5 and 6, which I suspect Sudoku would have proved anyway. And we're finishing off. And that is so clever. What an arrangement. And it's a really great solve as well. So there we go. That is the solution. Brilliant. Well, thank you, Bruce. That is really good fun. And a really clever solve. I mean, a really clever setting. That's brilliant. I mean, deserves a feature on this channel more than anywhere else because of our obsession with 3 in the corners, which we've really lent into today. Thank you for watching, as always. Hope to see you again soon on the channel. Bye for now.